This is 6-8, part 2. We're continuing to graph radical functions. In particular, we're going to focus on how to graph the cube root function. So the cube root function is the inverse to the cube function. So if we were graphing f of x equals x cubed, we know that that graph would pass through the point 0, 0, also through the point 1, 1, and through the point negative 1, negative 1, and it would look sort of like this. The cube root is the inverse to the cube, so that means we will have the point 0, 0, the point 1, 1. If you switch it, you still have 1, 1, switching x with y for an inverse, and the point negative 1, negative 1, also when you switch x with y, you still have negative 1, negative 1. So it goes through all the same 3 points as the x cubed function. The difference is that it goes sideways instead of vertically. So this is the cube root function as a graph. And if we put the y equals x line through here, we have symmetry through the line y equals x. So the red line here is the parent function for the cube root. So dealing with the cube root in particular, if we have the parent function to the cube root is this sideways line. So if we have a reflection, that means we have this negative on the front. That means the values are reflected across the line, the x-axis. So our point 1, 1 gets reflected down here. Our point negative 1, negative 1 gets reflected up here. So if there's a negative, then it goes more like that. If you have the a value here, let's say this is a cube root. If a is, let's say, 4, then that point that's normally at 1, 1 is going to be over 1 up 4. So it gets stretched. And the point that's normally here at negative 1, negative 1 gets stretched down 4 also. And so then the graph becomes much taller in the middle here. And then again, the minus h and plus k are the horizontal and vertical translations. So a minus h is going to go right. And when we say right, we're talking about this point in the center. The center point is going to go right. And if it says plus h, it goes left. Minus k will go down. Plus k will go up. So we have a graph here. The center point that's normally at the origin is going to go left 1, down 4. So left 1, down 4 puts us here. This is the middle point. And then the 2 here on the front is going to make the graph stretch. So the point that's normally over 1, up 1 is over 1, up 2. And the one that's normally left 1, down 1 is left 1, down 2. So we have the cube root function here that's been stretched. Okay, here's another one. On this one, the 3 has been put on the front, but that 3 is actually our k value. The negative here is a reflection. The negative goes to the 1/2. So the minus 2 means we're going right 2. The 3 on the front means we're going up 3. So we're going right 2, up 3. And then the negative 1/2 means we're going over 1, down 1/2, and left 1, up 1/2. So this one has been compressed by a factor of 1/2 when we draw our sideways curve. Okay, finally, if you have a square root function that's written such as this one, and we want to be able to describe the transformations, we'll need to factor first. So we'll factor out a GCF for the 9 and the 18, which is 9. That leaves us with x plus 2. Since 9 is a perfect square, we can take the square root of it. So we have 3, and then we still have square root of x plus 2. So here is our function in a different form. So from this, we can see that we have a horizontal translation that goes left 2. And then we have a vertical stretch of 3, so over 1, up 3. This is the graph of that, which is equivalent to that. Okay, here's another one with a cube root on it. The first thing we'll do is factor out a GCF. So the GCF of 8 and 32 is 8. So that leaves us with x plus 4. The cube root of 8 is 2. So we have 2 cube root of x plus 4. So the plus 2 that's hanging off on the end here, or the minus 2, I mean, that's still there. It's not affected by the factoring that we did under the radical. So for this graph, we're going to go left 4 and down 2. That'll be our center point. And then we have a stretch of 2. So from our center point, we go right 1 up 2, left 1 down 2, and then draw the sideways curve for our cubic function. And that's it for graphing cubic functions.